All right, hello guys. All right, we're going to try this lesson. Look at me, sorry, instead of the board. So you should have your book. You should turn your book. We're going to skip a couple lessons here. We're skipping 13.3, 13.4. Turn to page 722, which is 13-5, which is reflections. Okay, so we're talking about different types of transformation. Let me mention quickly, because Dr. Hickey wanted me to, we skipped a couple lessons on locus, but he wanted you to at least be familiar with locus is. Locus is the Latin word for place. It's the same word that shows up in location and locale and locate. That's a basic idea. So in mathematics, a locus is a set of points that satisfies a given condition or a given set of conditions. For example, we've talked about these before. The set of all points in a plane that are a given distance from a given point is the locus of a circle. That given point is the center of the circle. The given distance is radius. If you drop the words in a plane and say the set of points a given distance from a given point, that becomes the locus definition of a sphere, where the given point is the center of the sphere and the given distance is a radius. So he at least wanted you to be somewhat familiar with the concept of what a locus is. All right, so we're on page 722, 13-5, reflections. We're going to look through the lesson here and look at the book and look at some examples, and then we'll do most of the homework assignment together, okay? All right, and you can go ahead, so you should have your paper out. This is homework 16, and it'll be numbers 16 through 42. 16 through 42 on pages 726, 727. I'm not going to write on the board. It's going to be when I post this lesson in Google Classroom, the assignment will be right there, plus it's going to be in RenWeb, right? And that is basically going to be due on May the 12th. The assumption is you're doing this lesson on about May the 11th, and so it's due on May 12th. So we'll do basically 3-4 lessons this week, and that'll pretty much finish this up. All right, so we're talking about reflections. So you guys are familiar with reflections, all right? So reflection is a type of transformation, and basically it's a flip, is a term you might have used. So, so to reflect, you have to reflect over something. So you can reflect over a line of reflection. If you click on page 722, it shows you point P reflected over line L. So P is what's called the pre-image, and point R is what's called the image, and it's reflected over line L. And so that line L is called the line of reflection. You can also reflect over a point. If you look down further on the page, it shows you where point Q is the point of reflection, and even the same picture, we could argue that point P is reflected over or in point R. Some textbooks use the term of reflected in a line of reflection instead of through a line of reflection or over a line of reflection. So in this case, point P again is a pre-image, point Q is the image, right? All right, you need to understand some things about reflections. All right, in geometry, a reflection is basically an isometry. It's an isometric reflection. In other words, we don't change shape or size, we just change orientation. So basically, if we reflect, if you're looking on page 723, shows you triangle ABC being reflected over the y-axis, and so XYZ, triangle XYZ is a reflected image of triangle ABC. And so what we have is the two triangles are congruent. They're just different orientation. They're reflected images. So what we say is that this type of transformation or reflection preserves collinearity, preserves betweenness of points, preserves angle measures, and preserves distance measure. In other words, none of those things change. And so basically, if you go ahead and turn over to the next page, page 724, there's some pictures at the top of the page here. You're going to do some of this in the homework. A line of reflection can also be drawn through some plane figures. So we choose the correct line of reflection, that gives us a reflected image. For example, the letter C, if we draw a horizontal line there, then the upper half is a reflection of the lower half. Same thing with the arrow in the middle. That line of reflection creates a reflected image. rhombus on the right, or basically you actually have two lines of reflection. You can have a horizontal line of reflection. You can have a vertical line of reflection. Example 2 shows you, says determine and show all the lines of symmetry for each figure below. You'll have to do that on the test. If you have an equilateral triangle, there are actually 3 lines of reflection as shown in the picture. A line segment actually has 2 lines of symmetry. Notice, of course, in part B there, example 2, that line, the one line of symmetry actually is a perpendicular bisector. And that's one way of finding images, right? Example 3 says draw the reflected image of triangle PQR over the x-axis. All right, so we have an x-axis, which means if we reflect over the x-axis, that's why it's sometimes called reflecting in the x-axis, because the x value does not change. Point P has an x value of -2 and a y value of 4. If we reflect over the x-axis, then point P prime has still the same x value, still -2, and then the +4 becomes -4. If you look at point Q, your x value is -4, and Q prime is still -4. But when you reflect over the x-axis, point Q has a y value of -1. When you reflect over the x-axis, then the y value becomes +1. And point R, similar thing. Point R is 4 and 1. You reflect it over the x-axis, it remains 4, but the +1 becomes -1. So in a reflection over the x-axis, the x-coordinate always stays the same, and the y-coordinate is the opposite of the y-coordinate of the pre-image. Positive becomes negative, negative becomes positive, okay? And so that's what you can do, like in example 4. All right, and then the bottom of page 725 shows you another point of symmetry. We can have lines of symmetry. You can also have points of symmetry as well. So you can read that. So take your time, whatever you need to do to read those examples, look at those examples, add whatever notes you want to, and then we go to the homework assignment. All right. So homework assignment is on page 726. Again, homework 16, number 16 through 42, 726 through 727. All right, we'll do parts of this together and other parts I'll leave for you. So we'll do 16 through 23 together. So it's in the figure below, name the reflected image of each figure over the line M. So in the picture, you can see that line M is a horizontal line. So you're kind of guessing what appears to be the reflected image. So if you look at point A, then you go down from point A, there's point C. So the answer to 16 is point C. 17, segment FG. If you find segment FG on the right side there, then the reflected image would be segment HG. Make sure you write this segment symbol over HG. Segment HG. Number 18 is angle ABE. That's angle Lincoln there. So ABE, the image of angle ABE would be angle CBD. Again, email me with your questions if it doesn't make sense to you. All right, 19 is angle ABC, and the reflected image of angle ABC would be angle CBA. It's the same angle basically. Same thing with 20. The reflected image is segment BG. Well, segment BG lies on line M, so therefore the reflected image remains segment BG. 21 is triangle BFG. So triangle BFG is the upper triangle. So you flip it over to triangle BHG would be the reflected image. 22 is angle GBF, and the reflective angle of angle GBF would be angle GBH. All right, last one, 23, quadrilateral FGHB. Again, feel free to go back and watch this over again, send me questions or whatever. Quadrilateral FGHB, the reflected image would be quadrilateral HGFB. All right. Okay. Pause, whatever, get caught up. All right, now let's look at 24 through 27. 24 through 27, you're going to do on your own, okay? 24 through 27 says copy each figure, draw all possible lines of symmetry. If none exist, write none, okay? So I'm going to have to see the picture copied and you trying to do those, okay? 24 should turn out to be none, but I still need to see the picture and the word none. 25 is a letter T. In reality, is there's just one possible line of symmetry, and that's a vertical line through the T. 26 is X. I need to see the picture and the lines drawn. And again, though, there should be both a horizontal and a vertical line of symmetry. And then 27 point D, again, I need to see the picture and I need to see a horizontal line of symmetry. All right. Again, stop, whatever you need to do. All right, then 28 through 33 is also on your own. It says copy each figure, use a straight edge to draw the reflected image of each figure over line P. All right. So that's 28 through 33. Do the best you can. Just give me something that looks like you drew the best you could and try it. Copy means like to trace it. You can trace it or draw something that looks very similar. All right, again, pause the video, whatever, take time to get through this. All right, the next group is 34 through 39. It says for each figure, determine whether line L is a line of symmetry. Write yes or no, explain your answer. And the answer really fits in with the definition. And if you look in the back of the book on number 35, that's going to give you what your answer should look like at the beginning there. So 34 says, so is line L a line of symmetry? Well, yes, it is. Okay, why is it yes? All right, you write this. And again, line L is a line of symmetry because it is possible to find for every point A, another point B, so that line L is the perpendicular of bisector segment AB. All right, if you look in the back of the book at 35, it's the same answer as 35. So I'm not going to repeat it or write on the board for you. Just copy down the answer 35 for 34. And then 35, the same thing as line L, a perpendicular bisector. Yes, because that's a square. So yes, line L is a line of symmetry because it's possible to find for every point A, another point B, so that line L is a perpendicular bisector of segment AB. So that's the same answer for 34 and 35. So copy that from the back of the book for 35, and you'll be able to do it for 34 and 35. All right. Again, pause whatever you need to do to get those answers down. All right, 36. All right, 35 was a square. 36 is not. 36 is a rectangle. So therefore, it's not going to be a line of symmetry. If you fold that, you would see it doesn't match. So the answer to 36 is no. The simple answer for that is not all points are the same distance from line L. So I'll say that again. Not all points are the same distance from line L. I'm not going to repeat. You can keep repeating the video until you get it down. All right, 37. 37, okay, technically the pictures don't match exactly, but let's assume they do. And by the way, a little real world information here, it doesn't work in real life. If you draw a line of symmetry down through your face and do two mirror images, you'll get different people, especially people like me, where one ear is higher than the other, my nose is crooked, and one eye is higher than the other. And really some of us are more crooked than others. So. All right, so, but technically their answer is yes. And it's the same as the answer for 34 and 35. Yes, line L is the line of symmetry because it is possible to find for every point A, another point B, so that L is the perpendicular bisector of segment AB. All right, same answer. And don't throw away points, guys. 34, 35, and 37 are the same answers, but I expect to see them all written out 3 times. If you say the same as whatever, I'm not going to count that. So take a little time, get your points, okay? Time's running out on getting grades. These are the last few grades we're doing here. By this time, you've finished the chapter 12 tests, and there is no other test. So the only way you can fix your grades or ruin your grades is with homework assignments. All right, 38. Again, that's obviously a hand that obviously doesn't work. So that's the same answer as 36. No, because not all points are the same distance from line L. And then 39, obviously that's not going to work. That's going to be no. Also, same answer. Not all points the same distance from line L. Again, if you want to look in the back at 39, that'll show you how to write the answer for 36, 38, and 39. All right, 40 says in example 3, what pattern do you notice when there's a reflection over the x-axis, okay? All right, and we talked about that back when we were looking at that. The x-coordinates of the pre-image and the image are the same. All right, the x-coordinates of the image and the pre-image are the same. However, the y-coordinate of the pre-image is the opposite to get the y-coordinate. It's negated. If it was negative, it becomes positive. If it's positive, it becomes negative. Basically, If you go back to page 724, example 3, in that last paragraph, just copy that last paragraph. In a reflection over the x-axis, the x-coordinate remains the same, and the y-coordinate is the opposite of the y-coordinate of the pre-image. Just copy that. That's your answer to 40. All right, 41 and 42 requires graph paper. And for 41 and 42, it says graph each image on the coordinate plane, then draw its reflected image over the indicated line of reflection. So for number 41, you'll graph segment AB. They give you the coordinates, and then it says reflected over the x-axis. So remember, if it's reflected over the x-axis, the x values remain the same. So A prime would be x value is 4, B prime, x value is 0. And then the y-coordinate is flipped. So A is 4 and 3, its image would become 4 and -3. B is 0 and 3, so that would become 0 and -3, and just draw your new segment. All right, same thing for 42. But a little harder, trapezoid ABCD. So you draw a trapezoid ABCD, they give you the coordinates, and then it says graph over y equals 3. So this is not the x-axis, but it's similar. So basically you graph ABCD, then you draw your horizontal line, y equals 3. And since it's a horizontal line, then the x values are not going to change. But since it's y equals 3 and not y equals 0, basically you count how many points something is above y equals, and it's that many points. Y equals, you count the number that you're above y equals 3, and then you're that much below. And if you're below y equals 3, then you count those, how far you are below 3, and it's that much above, all right? So that's it. Have fun with that. And again, this is a little bit of work, but we've done most of it, and it should be easy to get 100 on this. Need to finish well. All right, enjoy.